Hello everyone, my name is Amma Hamand. For this video, I will showcase a cloud storage integration solution that is supported on our Catalyst 9000 switches. The use cases realized with this solution enable the acceleration of cloud adoption within the network management space. First, I will give a brief overview of what this new solution is and provides, the different use cases that can be realized, and a demo that shows this new solution in action on our Cat9K switch. So essentially, what's happening with this new solution is that our Cat9K switches can now integrate seamlessly with cloud storage accounts, specifically the AWS Cloud account, through a shared data streaming connection that is secured by TLS. And from this data connection, customers can utilize the different AWS cloud services available within their account to then optimize their network management and operations. In this release, we have integration support for two AWS cloud services, which is the AWS S3 and the AWS CloudWatch service. This solution is available on the 9300 and the 9500 switches, running the IOXC 1715 with a DNA Advantage license. Now, using these cloud services provide the customer with multiple benefits. Let's take a look at some of them. Businesses can reduce the cost associated with maintaining on-prem storage infrastructure since S3 and CloudWatch offer a pay-as-you-go model, so you only pay for what you use. This leads to significant cost savings as there's no need to invest in and maintain expensive on-prem infrastructure. AWS S3 can also be used to store large volumes of files, including logs and configuration files from network switches. This allows businesses to easily scale their storage needs without having to worry about the limits of using on-prem hardware. Storing network configurations and logs in the cloud and across multiple locations ensures that the data is always available and reliable in cases of hardware failure or other disasters. Finally, by integrating with AWS, companies can more easily adopt newer technologies like machine learning and big data analytics to gain insights from their network traffic and operations. So as shared earlier, there are two use cases with this solution we would explore. First is the AWS S3 Cloud integration. S3 is a highly scalable object storage service that is offered by AWS and is ideal for storing and retrieving any amount of data. We are finding that there are currently multiple requirements from network admins for the easy distribution of files to multiple devices in a secure manner and to have more inbuilt storage available on the switches. With this integration, now they can store large volumes of files in S3 and then seamlessly distribute them to multiple Catalyst switch devices that are in different sites, that are also connected to that same S3 bucket instance. We can also supplement fixed storage capabilities of the Cat9K switches with cloud-based storage. Use cases that can be realized include being able to upgrade switch images with files that are in the S3 bucket, store critical backup files like running configs from switches into a central S3 bucket, and distribute files to multiple switches. Second is the AWS CloudWatch service. This is a monitoring and logging service that analyzes data and gathers insights from syslogs and helps you to take appropriate actions, create graphs, and correlate the log patterns within the syslog, all in a single dashboard. Traditional syslog management approaches may not be capable of managing the volume of logs that are generated by a growing organization. With this integration, businesses can centralize large volumes of syslog data from multiple switches in different locations. They can also configure to trigger alarms or automated actions based on specific events or thresholds in the syslogs. The logs are stored in a persistent storage in the AWS platform, and so this helps in the in-depth analysis of network trends over a very long period of time. Let's take a look at the configuration steps for the AWS S3 integration on the switch. First, we configured an S3 profile on the switch. We then configure AWS credentials that are required to authenticate and connect to the AWS Cloud Agent. These IAM credentials can be generated in your AWS user account. Linked below is a document that shows the steps to be able to do this. We then configure a mount point that creates a shared folder that maps the S3 buckets to the switch local file system or directory. The shared folder is where we can access the files that are stored in the S3 bucket from the switch. There is a .cloudfs directory that is created on the switch upon boot up. The directory name we put here is created as a subdirectory under the .cloudfs directory on the switch. We then configure the region of our S3 buckets, our permissions for read and write of the file, configure a proxy if it's used in the network, and then the VRF interface for the connection interface. We then no shut to start the S3 service. To configure a CloudWatch integration, we follow steps that are similar to S3. First, we create the CloudWatch profile. Then, we configure AWS IAM credentials. Then, we configure log group name and a log stream name that will show up in our CloudWatch account. The log group name could be the group name for switches in a specific site, and the log stream name the syslog stream for the specific device. We will also configure the file path. This file path shows where the logs of the switch are stored for retrieval by CloudWatch. The star at the end indicates that all files within the directory are to be sent to CloudWatch. We then configure the region, the proxy, and the VRF as done in S3, and then no shut to start the service. Let's take a look at some of the requirements to ensure the successful enablement of the feature on our switches. First, you need to have an AWS account and an IAM user account with access key and secret key credentials. Linked below is a way to generate these keys. You need a Cat9K switch with internet connectivity to be able to send data to AWS, and the Cat9K switch needs to be running a 17.5 version and above. And most importantly, ensure that the clock set on the switch is accurate to prevent delays in syncing with the AWS account. Let's go ahead and look at the demo of the solution in action. To start up this demo, let's take a look at the configurations we have on our switch. We have an S3 profile of test1 configured. We also have the access key and the secret key configured, encrypted as well. We have a bucket name of Cisco user and a mount point folder of test bucket configured. We have the permissions set to read and write and the region configured. Let's take a look at the test bucket subdirectory to see what files we currently have in it. To test this use case, we will upload a file from our local machine into our S3 bucket and be able to access this file on our switch. We will now go into our AWS user account and access S3. In the S3 dashboard, we will select Cisco user, which is the name of the configured S3 bucket. In the Cisco user bucket, we can currently see there are no files. We will select Upload, Add Files, and then select a file. Select Upload, and once successful, we can see that the hello.txt file is currently present in the bucket. We'll go back to our switch and check the directory to see what files we can access from our switch. And as we can see, we currently have the hello.txt file available in our switch file system. This use case provides easy image management and image distribution to multiple switches, all connected to this AWS bucket, as the files are made available in the shared folder on the switch. Now, let's take a look at the configured CloudWatch settings on the switch. We currently have a CloudWatch profile of test2 configured. We also configured the AWS IAM credentials. We configured the log group name of test log and the log stream name of this switch as test stream. And this test stream is what will show up in our CloudWatch account. We also configured the file path of bootflash/CloudWatch configured. And we have the region configured and the no shut. We will now show how network admins can easily store large amounts of log files and share them with other AWS users in their organizations who may not have access to these switches. These syslogs can then be shared with others for debugging, troubleshooting, without the need to download log files directly from the switch. We are going to go into our CloudWatch account. In CloudWatch, we are going to select View Logs. We are then going to select our log group, which we configured as test logs. And we can see the retention here as 10 years, and so we are able to monitor these logs over a very long period of time. Once we select this log group, we can see our device details here, which is the test stream. Once we select test stream, we can now see the syslogs populated within our CloudWatch account. We can now automatically generate alarms, alerts, and notification. We can filter based on the relative time that we select as well. When we select Log Insight, we're able to do multiple things here. First, we can select the fields in which we would like to see our syslogs. Here, we selected timestamp, message, logstream, and log by default. We can also have a limit of 10,000 logs populated at once. We then select our log group, which is test log, and then run the query. And so below, we can see our syslogs currently populated based on the fields that we selected in the query. That's the demo of the AWS Cloud Integration solution on our Cat9K switches. Please leave any questions below regarding this video that you may have. Thank you for watching, and goodbye.